Today we'll start a new lesson. This is the fourth lesson of the NCERT textbook, Determinants. The name of the lesson is Determinants, and in this lesson we will first of all understand what is meant by determinant of a matrix. So determinant is a special real number that is associated with a matrix. So every matrix has got a special real number associated with it, and that real number is called determinant. To understand what does determinant signify, let us consider linear equations in two variables. So suppose our equations are x plus 2y is 3, 3x plus 4y is 5. Another pair of equations, x plus 2y is 3, 2x plus 4y is 6. And a third pair of equations, this. Now we have studied in lower classes to an algebraic method to find out the kind of solution a pair of linear equations can have. So the algebraic method says that a1 upon a2, if it is not equal to b1 upon b2, then the equations have a unique solution. If the two ratios are equal and also equal to c1 upon c2, the equations may have many solutions. And for a pair of equations to have no solution, this is the condition. So let us use these conditions and find out what kind of solutions do our equations have. So considering the first case, a1 upon a2 is 1 by 3, b1 upon b2 is 2 by 4, and we know these two are not equal. So the first set of equations has got a unique solution. In the second set, substituting 1 by 2, this value is 2 by 4, this value is 3 by 6, all the three ratios are equal. So we know in this case, the set of equations have got many solutions. Likewise, moving on to the third case, the ratios 1 by 2, 2 by 4, 3 by 7. The first two ratios are equal but not equal to the third ratio. So in this case, the set of equations have no solution. So in all the three conditions, let us basically focus upon the comparison of first two ratios. Why are we comparing the first two ratios? Because the first two ratios basically give us the coefficients of x and y in these equations. Look at this condition. The condition is 4 not equal to 6, which can also be written as 4 minus 6 not equal to 0. The next condition gives us 4 equal to 4, which gives us 4 minus 4 equal to 0. The next condition also gives us 4 minus 4 equal to 0. Right? So now when you simplify the left hand side of these equations, you obtain a real number 2. On simplifying this left hand side, we obtain 0. Simplify the left hand side, we obtain 0. So these numbers that we have obtained on simplifying the left hand side is the special real number we are looking for. So these numbers are called determinants. In the first case, the determinant is not 0. So I'll write down here. The determinant in the first case is not 0. If the determinant is not 0, a set of linear equations will have a unique solution. In the second case, the determinant is coming out to be equal to 0. In the third case also, it is 0. So here we have two situations. A set of linear equations may have many solutions or may have no solution at all. So this is how we get to know that we have a special real number, which basically tells us what kind of a solution will a pair of linear equations have. Now here I have written determinant of a matrix. We have determinant, but now the question is, where is the matrix? So now to understand where is the matrix, let us focus on, say, the first set of linear equations. The first set of linear equations can be converted into the matrix form like this. Because we are aware of matrix multiplication, so the first matrix will have the coefficients of x and y. The second row will have coefficients of x and y of the second equation. Here we can write down the variables, and on the right side the constants. You can check, it is a 2 by 2 matrix. This is a 2 by 1 matrix. Columns and rows are equal, so multiplication is possible. The resultant matrix is of order 2 by 1. So now the same set of linear equations has been converted to a matrix equation, and the matrix equation can also be written like this. So this is what is matrix A. We are right now interested in this matrix. So the equations converted to matrix form, and now this matrix, when you find out its determinant, find out the determinant of matrix A is symbolically written like this, and it is equal to 4 minus 6, which is minus 2. This was the same number we were obtaining here. So this is what is a special real number called the determinant. So determinant of A is written like this, which can also be written in short this way. You have to understand that this is not modulus of A. Alright, this is read as determinant of A. It is not the absolute value of A. So now we'll see how to find out the determinant. So whenever we find out determinant of a matrix, it has to be well understood that the matrix is a square matrix. Whether it is mentioned or not, it has to be a square matrix. So if we take a matrix A of order 1 by 1 this way, then the determinant of A is the real number, that is 4 in this case. If it is a determinant of order 2, a matrix of order 2, the determinant of the matrix is obtained by multiplying the diagonal elements and subtracting from it the product of off-diagonal elements. So the determinant comes out to be minus 2. If we have a 3 by 3 matrix, let us see the 3 by 3 matrix is this. So now to understand how to find out this matrix, this determinant, I'll just write down the matrix in its elementary notation like this. The second row elements and the third row elements. A matrix of order 3 by 3 has got 3 rows and 3 columns. So when we say that we are finding out here determinant of the matrix, that means, let me write it down here, determinant of the matrix basically means expansion of the matrix. Now since the matrix has got 3 rows and 3 columns, so that means this expansion can be done along any one of the 3 rows. The expansion can be done along any of the 3 columns. So to expand the matrix, we have basically got 6 ways. So for this matrix, suppose we want to find out the determinant A by expansion along first row. So over here, look into the first row elements. Something special is there with the elements. The sum of subscripts is even. The sum of subscripts 1 plus 3 is even. This is a special element where the sum of subscripts is an odd number. This is a special element, so whenever we use this element to find out the determinant, this element will change its sign in the matrix. So when we are expanding along the first row, whenever we come across 2, we'll write down -2. Let's see how. The first element of the row is 1. Here 1 has to be multiplied by a determinant. Which determinant is that? Because this element is present in first row, delete the first row. The element is present in first column, delete the first column. These are the elements left. So we'll find out determinant of 1, 2, 3, 1. Then next, this is that special element. Its sign will change and we will multiply it by some determinant. Which determinant is this? Now to find out that determinant, this is the element. The element is present in first row, delete first row. It is present in second column, delete the second column. So the elements that are left with us are 2, 3, 3, 1. The last element of the first row is +3 to be multiplied by some determinant. If we are finding out the determinant corresponding to this element, the element present in first row, third column, and the remaining elements left is 2, 3, 1, 2, and simplify further. So 1 minus 6 minus 2 times 2 minus 9 plus 3 times 4 minus 3. So we have here -5 plus 14 plus 3, which is equal to 12. So the determinant of this matrix is 12. Since the expansion of the matrix can take place in 6 ways, whichever way, along whichever column or row do we expand the matrix, the value of the determinant does not change. So now let us expand it along the second column. Let us find out the determinant along column 2. So to find out the determinant along C2, look at the second column and find out which are the special elements here. So looking into the second column, this is that element where sum of subscripts is odd. Hence these two elements, that means these two elements will change their signs. So starting with the first element, this element is -2 to be multiplied by some determinant. The element is in the first row, second column. So we get here numbers like 2, 3, 3, 1. The next element does not change its sign. This is to be multiplied by some determinant. So the next element is this, present in second row, second column. So the elements we are left with are 1, 3, 3, 1. The last element of the second column is again a special element. So it will change its sign and multiplied by some determinant. The last element -2, so delete third row, second column. The elements are 1, 2, 3, 3. And now expand. We get -2 multiplied by 2 minus 9 plus 1 multiplied by 1 minus 9 minus 2 multiplied by 3 minus 6. This gives us 14 minus 8 plus 6, which is 12. So whether the expansion takes place along any column or any row, the value of the determinant does not change. So in some of the books, determinant of any matrix may also be represented by this symbol. We read it as the delta symbol. Alright, so since now we know what exactly is a determinant and how to evaluate the determinant, we will solve some questions from exercise 4.1. So starting with exercise 4.1, we'll take up second question. first part, and the first part asks us to evaluate this determinant. So multiplying diagonal elements, cos square theta minus product of off diagonal elements minus sine square theta, and using basic identities of trigonometry, we know the result is 1. The second part of this question, expressions are given of this kind. Now here again, let us multiply the diagonal elements first. X plus 1 multiplied by x square minus x plus 1 minus product of off diagonal elements, x plus 1, x minus 1. So here, if you remember this identity, directly use the identity. It is like x plus y into x square minus xy plus y square. So this identity is x cube plus 1. Here again, the identity is x square minus 1. Simplifying, x cube minus x square plus 2. So if you remember identities, you save your time of simplification. In case you don't remember identities, you will have to multiply the algebraic expressions and simplify to get this result. Next, we'll try a question number 4. A matrix of order 3 by 3 is given. The first row 1 0 1, second row 0 1 2, third row 0 0 4, and we have to show that determinant of 3a is 27 times determinant a. So let's start with the left hand side. Left hand side, look at this. This is 3a. 3a means scalar multiplication. So we'll multiply each element of matrix A by the scalar 3. So we will obtain this determinant 3a, multiplying each element by 3. And the third row is this. So here, since we are evaluating the determinant of order 3, we will try to choose that row or column which has got maximum number of zeros. As you can see, the first column has 2 zeros, the third row also has 2 zeros, so I will prefer to expand along column 1. So in the column 1, the special elements, there are no special elements, so expansion along 3, deleting first row and first column. The matrix, the determinant that we obtained is this, 3 times 36, which is 108. So simplifying the left hand side, we are getting 108. Now on the right hand side, 27 times determinant A. So determinant A, this is the matrix A. Here again in the first column there are 2 zeros. So we'll expand along the first column and we have 27 into 1 multiplied by this determinant, which is 1 0 2 4, and we get 27 into 4, which is 108. Hence we get to know that the left hand side is equal to the right hand side. So this is how we have shown the required result. Next we'll take up here question number 7. Seventh question, say the first part. A determinant equation is given. The first determinant 2 5 4 1. This is equal to the determinant on the right hand side, first row, and the second row is this. So here again evaluate this determinant, which is 2 minus 20 on the right side. Evaluate the determinant 2x square minus 24. So minus 18 plus 24 is 2x square. 6 is 2x square. Hence we get x square as 3. and therefore value of x is plus minus root 3. So we are able to find out here x. Now here you have to understand that this symbol that we are using here clearly indicates that this is a question on determinants. Please do not get confused that these are matrices and use the concept of equality of matrices. Suppose you use the concept of equality of matrices thinking that these are matrices, you would compare and write down this, which gives you x is equal to 1, which is not the right answer. Alright, moreover, when you compare the other elements, these two elements are also not equal. So understand the difference between the symbols of a matrix and determinant, understand the concept, and then apply the concept to find out the values of x. So with this question, we have finished exercise 4.1. In the next class, we shall be discussing properties of determinants.